In this video, we'll be talking about amplitude and period of sine and cosine. The amplitude for the two equations y equals a sine x or y equals a cosine x, the amplitude of the function is the absolute value of a. Now notice that we're not concerned when we talk about the amplitude, we're not concerned with whether the coefficient is positive or negative. The amplitude is merely the height of the graph above and below a horizontal line passing through the middle of the graph. So the amplitude is our absolute value of the coefficient, and then we'll use the sign on the coefficient, either positive or negative. We'll use that for graphing purposes, whether it goes up or down from its initial starting point. So our first example when we're talking about amplitude is to graph y equals 1/2 sine x and compare that to y equals sine x. Now the only difference in the equations is the coefficient of sine x. The one that we're graphing has a 1/2 coefficient, and the other one that we're comparing it to has 1 coefficient. So the only change is that when I graph the 1/2 sine x, my maximum and my minimum are going to be at 1/2, because the amplitude is how far up from the center line you go, and then how far down from the center line. So since this is 1/2 amplitude, then I only go up to a positive 1/2 and then down to a negative 1/2. Next, we're going to talk about period. Period for y equals sine bx. Notice that the number that we're going to have in our equation is the coefficient of x this time. On the previous example, it was the coefficient out in front of the sign. So for y equals sine bx or y equal cosine bx, you need to write this formula down. This is the formula for finding the period of the curve. The period is equal to 2 pi over b. So our first example, we're asked to graph y equals sine 1/3 x and compare it to the graph of y equals sine x. Well, we can see that b is 1/3, and we know then that the formula for period is 2 pi over b. So for our example, it'll be 2 pi over 1/3. This simplifies to 6 pi if we multiply top and bottom of this fraction by 3. So since our period is 6 pi and we've not done any other adjustments to the curve, I'm going to start at the origin and end at 6 pi. We also see that our coefficient out in front here is 1, so my amplitude is 1. So it'll have a max of 1 and a min of -1. So as far as comparing to y equals sine x, my period changes from 2 pi to 6 pi. On this example, we're asked to graph y equal cosine 1/2 x over 1 period. We can see that b is 1/2, and using our formula for period, we get period equals 2 pi over 1/2. Multiplying top and bottom of this fraction by 2 gives me a period of 4 pi. So that means our curve starts at x equals 0 and ends at x equals 4 pi. The coefficient here in front of the cosine 1/2 x is 1, so our amplitude is 1. And I didn't label that because we were mostly concerned about the period. Alright, our next example, we want to graph y equals -3 sine 2x over 1 period. Notice here on the amplitude, we have 3. Amplitude, again, let me remind you, is the absolute value of this coefficient. So the amplitude is 3. When we go to graph, though, since I'm doing sine, it'll start at the origin and head down instead of heading upward like the usual sine curve does. All right. Also, our b value is 2, so the period is 2 pi over 2, which means the period is pi. So we're going to start at the origin and end at pi. That was determined by this 2 pi over b. And we're going to have an amplitude of 3, which means I need to mark off a maximum of 3. So when I hit my maximum point, it will be at 3. And a minimum at -3. And then also because the coefficient is negative, I have to head down from the origin rather than up. One more example. I'm asked to graph y equals -2 cosine pi over 2x. Again, my coefficient of my cosine curve is -2. The amplitude is +2, but my cosine, instead of starting at +1, like a cosine curve starts up at +1. Here's another cosine curve. Instead of starting at +1, in this case it starts at -2. Also, my period, I need to calculate what that is, so I write 2 pi over 2, because b is pi over 2. So multiplying top and bottom by 2, and then my pi's will cancel off. That gives me a period of 4. So I label my horizontal axis, starting at 0 and ending at 4. And remember, when you notch off your x-axis, you want 4 spaces to represent the 4 quadrants. And so I start down here at -2 and hit the axis, and then hit the max, hit the axis, and hit the min.